Hi everyone, so welcome to week 6 for junior cycle ordinary level. Today we're going to be focusing on indices and the laws of indices. So we're going to be going through the different laws and how to apply them to different exam questions. And at the very end of the lesson then I'm going to go through some exam questions pulled from papers. So I'm going to start with a very simple example. So I'm going to put down example 1 here just to explain what indices are. So I'm going to write down 3 multiplied by 3 multiplied by 3 multiplied by 3 equals what? So when we're using the laws of indices, so you can see there that they're all the same number. So we have 3 by 3 by 3 by 3. So we have 4 of them. So that means it's going to be 3 by 3 by 3 by 3 gives us 3 to the power of 4. And it's to the power of 4 because we have 1, 2, 3, 4 of them. So when we're using proper terminology, we say that, so 3 to the power of 4, the 3 would be the base. Okay, so 3 is the base. And 4 is the exponent. So that's what it's to the power of. So 4 is the exponent. So we can actually calculate powers of any number successively by multiplying the previous power as follows. So 2 to the power of 1 is going to give you 2. 2 to the power of 2, that's 2 by 2, that gives you 4. 2 to the power of 3, that's going to be 2 by 2 by 2. That's going to give you 8. 2 to the power of 4, that's 2 by 2 by 2 by 2. And that will give you 16. 2 to the power of 5 then, that will give you 2 by 2 by 2 by 2 by 2. So that's going to give you 32. You could put this straight into the calculator. 2 to the power of 6, 2 by 2 by 2 by 2 by 2 by 2. And that's going to give you 64. 2 to the power of 7, so you have 2 by 2 by 2 by 2 by 2 by 2 by 2. And that will give you 128. So we're going to go all the way up to 2 to the power of 10. So 2 to the power of 8 then, you have 8 of them. So 2 by 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 2. So 2 to the power of 8 is going to give you 256. 2 to the power of 9 is 2 by 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 2. And that gives you 512. And last one, 2 to the power of 10. So we have 10 of them. So 2 by 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 2. And that gives you 1024. So you can see there why it's much easier to write it out as 2 to the power of 10 rather than writing 2 by 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 2. So it's much easier to write them out to the power of. And remember, say in this case, 2 would be the base and 10 would be the exponent. So the number that you're multiplying out is the base, and the number that's the power here is the exponent. So those terms are really, really important. So we're just going to look at index notation and power notation as well, just to make sure that we understand it fully. So I'm going to put this down as example 2. So for example 2, if we said that n, so we don't know what n is, but we said it was a positive integer. Now, another way of saying a positive integer is a natural number. So it's a positive integer or natural number. And if we said a was just another number, so it's a real number, we'll say. Real number. We know what real numbers are. from looking at our notation of natural numbers and integers. So real numbers, you're including everything. So n is a positive integer, which is a natural number, and a is a real number. So if we wrote down a to the power of n, a to the power of n, that would be a by a by a, and it would continue on. So you'd by a, and here you'd have n factors. So what that means is whatever this number here is, you multiply a out by that many times. So if n was 3, it would be a by a by a. If n was 10, you'd multiply a out 10 times. And that's just index notation. Just if you see that whatever the real number is, you're putting it to the power of the positive integer, which is n. Now, in addition to that, we would say that a is the base, and we would say that n is the exponent. So a is the base and n is the exponent. Now next we're going to actually go on to the rules of indices. So multiplication, division and power rules, and we'll go through them now on the next slide. So we are going to look at two rules. So the first rule, and this is the way that it will appear in your log tables. The rule is a to the power of m multiplied by a to the power of n gives you a to the power of m plus n. Now we're going to do an example just to clarify that. So if you had 2 to the power of 3 multiplied by 2 to the power of 2. Let's look at this for a minute. Because you have the same base, this is 2 and this is 2. So this only works if you have the same base. So this is 2, this is 2. So what we can do is add the exponents. So we're going to add 3 plus 2, and your answer will be 2 to the power of 5. And again, I'm going to reiterate that fact. I'm going to write it here, that bases must be the same in order for the rule to work. So bases must be the same in order for this rule to work. So that's a to the power of m multiplied by a to the power of n is equal to a to the power of n plus n, and I'm giving you an example there. So the second rule, and again this is how it will appear in the log tables, and it's going to be a to the power of m over a to the power of n is equal to a to the power of m minus n. Now again, the bases must be the same. So the value of a must be the same. So if they are the same, your answer is going to be a to the power of, so m take away n. I'm going to do an example just to clarify that as well. So if you had 2 to the power of 7 divided by 2 to the power of 5, because these bases are the same, your answer is going to be 2 to the power of, so 7 take away 5 is 2. And that's the answer there. And again, I'm going to put this rule in. So bases must be the same. Sorry, that should have a B up here. So bases must be the same in order for this rule to work. Okay, so bases must be the same in order for this rule to work. So we're going to do an example now as well. So this is example 3 actually. So example 3, and the question is, which is bigger? So which is bigger? (5 to the power of 12 or 3 to the power of 18? So you're being asked which is bigger, 5 to the power of 12 or 3 to the power of 18. So the best way to solve this is try and get these in similar terms. so that you'll be able to look at it and know straight away whether it's bigger or not. So I am going to look at 5 to the power of 12 first and see, can I rewrite that as something else? So with 12, what about writing it as 5 to the power of 2 by 6? And again, I'm using this rule here. So 5 to the power of 2 by 6. So 5 to the power of 2 by 6, you can rewrite it as 5 squared to the power of 6. That's the same because brackets mean multiply, so that's 2 by 6. So 5 squared gives you 25. It's going to be 25 to the power of 6. Now I'm going to do the same with 3 to the power of 18. I'm going to get it in similar terms. I'm going to try and get it as 25 or even 26, 27, something close to 25. So we can look at it and say, right, well, that's bigger or smaller. So 3 to the power of 18, I'm going to rewrite that as 3 to the power of 6 by 3 or 3 by 6, like so. So 3 cubed to the power of 6. Now, if you put into your calculator 3 cubed, you'd get 27. So that's going to be 27 to the power of 6. When you look at these, 27 to the power of 6 versus 25 to the power of 6, which is going to be bigger? Well, we know the 27 to the power of 6 is going to be greater than 25 to the power of 6. So now we go back to the original question. This means that 3 to the power of 18 is actually bigger than 5 to the power of 12. So that's using your laws of indices to try and solve problems. We're going to do some more examples now. So I've pulled a paper from 2016 and it's paper 1. So question 11. So I've put the first 3 parts up on this slide and I'll put the final 2 parts up on the next slide. So fill in the table by writing each expression in the form 2 to the power of p, where p is an element of n. So we know that n is going to be a natural number. So we're looking for a natural number for the value of p. So 1 has already been filled in for you. So 8 is 2 to the power of 3 because they want it in the format 2 to the power of something. So that's 2 to the power of 3, and in that case 3 is a natural number, so p is an element of n there. So we'll go on to the second one. 32, how would you write 32 in terms of 2 to the power of something? So you really need to use your calculator here, but if you multiplied 2 by 2, that will give you 4, so that's not going to work. 2 by 2 by 2, that will give you 8, so that's not going to work. What about 2 by 2 by 2 by 2? So that's not going to work either, because 2 to the power of 4 gives you 16. But what if we added another 2 there? So 2 by 2 is 4, 4 by 2 is 8, 8 by 2 is 16, 16 by 2 is 32. So that will work. So we rewrite that as 2 to the power of 5, because we had 2 to the power of 1, 2, 3, 4, 5. So if we look at the next one, how would you rewrite this in terms of 2 to the power of p? So we have 1, 2, 3, 4, 5, 6. So that's going to be simply 2 to the power of 6. So I'll put up the next 2 parts of that question on the next slide. So before I do the next 2 parts, let's write out our laws. So law 1 is a to the power of m multiplied by a to the power of n is the same as saying a to the power of m plus n. Then the second law that we looked at was a to the power of m divided by a to the power of n gives us a to the power of m minus n. Now remember, the bases have to be the same. So in this case, you have 2 to the power of 7 multiplied by 2 to the power of 10. So that's where this law comes into play. And it will work because this is the base is the same. You have a 2 here and you have a 2 here. So what we can do is add the powers or add the exponents. So we add 7 plus 10. So we'll write the full thing out. 2 to the power of 7 multiplied by 2 to the power of 10 gives us 2 to the power of 17. And the reason that worked was because we had the base the same, 2 and 2. So let's look at this next one. 2 to the power of 6, and that's in brackets, to the power of 4. Now what you can do here is actually multiply 6 by 4 because it's brackets. So we can rewrite that as 2 to the power of 6 to the power of 4 is the same as saying 2 to the power of 24. So we multiplied 6 and 4 together. So I'm going to put up another couple of questions now from exam papers and we're going to go through how to complete them. So this question is from 2014 and this is also paper 1. So the table below shows the values when 3 is raised to certain powers and you're asked to complete the table. So the first one there is done, the first two are done actually. So 3 to the power of 1, so expanded power of 3 is just going to be 3 because you have nothing else to multiply it by and the answer is 3. 3 to the power of 2 is 3 by 3, 3 by 3 gives you 9. 3 to the power of 3 is 3 by 3 by 3, so 3 by 3 by 3 will give you 27. So that's the answer there. So 3 by 3 by 3 gives you 27. And then we have 3 to the power of 4. So let's write that out properly. That's going to be 3 by 3 by 3 by 3. And that's 81. 3 to the power of 5 then we have to do this fully. So this is going to be 3 by 3 by 3 by 3 by 3. So 3 to the power of 5. And when you put that into the calculator, it's going to give you 243. So we'll go on to another question now. Question I have up here is the 2015 sample paper. So this 2015 sample paper 1. So question 7, write 2 by 2 by 2 by 2 by 2 by 2 in the form 2 to the power of x where x is an element of n. So n is a natural number. So we have 1, 2, 3, 4, 5, 6. That's going to be 2 to the power of 6. We're going to put in that box. So 2 to the power of 6. If we look at part B, a to the power of p by a to the power of 3 is equal to a to the power of 8. Write down the value of p. So if a to the power of p by a to the power of 3 is equal to a to the power of 8, write down the value of p. So remember the rule. So let's write out the law again. So the law is a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. So we'll check are all the bases the same. They are. We've a here, we've a here and a here. So what this means is p plus 3 is equal to 8. So I'll just actually write that out underneath. So p plus 3 is equal to 8. So how do we get what p is? So p is going to be 8, take away 3, which means p is going to be 5. So then if we look at part C, simplify 2 to the power of 5 by 2 to the power of 6 over 2 to the power of 4 by 2 to the power of 3. So this is actually bringing in both laws, and I'm going to write out the second law. So we have it. So the second law is a to the power of m over a to the power of n is equal to a to the power of m minus n. So let's do the multiplication bit first. They're all 2's, which means they're all the same base. So 2 to the power of 5 by 2 to the power of 6, we'll write it out properly, is going to be 2 to the power of 5 plus 6 over 2 to the power of 4 by 2 to the power of 3 is going to be 2 to the power of 4 plus 3. So 2 to the power of 5 plus 6 is going to be 2 to the power of 11 divided by 2 to the power of 4 plus 3 is 2 to the power of 7. Now we're not done because now we have to solve this bit. So we have it in a 2 to the power of 11 divided by 2 to the power of 7. So we're going to use this rule here. So we know that if the base is the same, which it is, this is 2, this is 2, we take them away. So it's going to be 11 take away 7. So that final answer is going to be 2 to the power of 11 minus 7. 2 to the power of 11 minus 7 is going to give you 4. So the final answer is 2 to the power of 4. So I've pulled another paper. This is 2019 and it is paper 1 as well. So if we look at the first question there, fill in the table below to show each number in the form 10 to the power of n, where n is an element of a natural number. So that letter n is going to be a natural number. So 100 is 10 to the power of 2. 10,000, you will get 10,000 if you multiply 10 by 10 by 10 by 10. So that's 10 to the power of 4. Next one, we have the same base. If you look at it, We have 10 to the power of 3 by 10 to the power of 9. So it's the same base, which is 10. So when we have the same base and it's multiplied, we add the powers. So we add 3 plus 9, and 3 plus 9 is going to give us 12. So the answer is 10 to the power of 12. And then if we were to write 10 in the format 10 to the power of n, well, 10 to the power of 1 will give you 10, so that'll work. So we put in 10 to the power of 1. If we look at the next question, write 5,400 in the form a by 10 to the power of n, where 1 is less than or equal to a, and that's less than 10, and n is an element of a natural number. So basically what they're asking you to do is put the number 5,400 into scientific notation. Now, because it has a by 10 to the power of n, so they just want one number on its own by 10 to the power of n. So the way I usually do this is I put in a decimal place here and I count back to the first digit, because they only want one digit, as you can see there. So if we count back 1, 2, 3, so that's going to become 5.4 by 10 to the power of 3. I'll just go through what I did there. So I'll put in a decimal place here and I count back as far as the first digit. So 1, 2, 3, and that brings me to 5.4. So 5.4 by 10 to the power of 3, because I went back by 3. And that's it in scientific notation. And just to double check, 10 to the power of n. So n in this case is 3. Is 3 a natural number? Yes, it is. So I'm just going to put in brackets here as well. So we know that natural number is 1, 2, 3, and so on. All the way. It can go all the way up to infinity. But remember, natural numbers, zero cannot be included, and you can't have a negative number. So remember, again, if you see n, it's positive whole numbers. So I pulled another paper here, and this is from 2012. So I pasted part A into this slide, and I'm going to do part B then. So if we look at part A, so you were given a table, and as you can see here, these are all 2 to the power of a number. Now when you expand them out, so 2 to the power of 1 is just 2. So your answer is 2. 2 to the power of 2 is 2 by 2. That gives you 4. 2 to the power of 3 is 2 by 2 by 2. That'll give you 8. So you need to put 8 into your answer here. 2 to the power of 4 is 2 by 2 by 2 by 2. And if you put that into your calculator, you get 16. 2 to the power of 5 is 2 by 2 by 2 by 2 by 2. So 2 to the power of 5 will give you 32. Then you have 2 to the power of 6, so that's 2 by 2 by 2 by 2 by 2 by 2. That's 2 to the power of 6, and that will give you 64. Then we have 2 to the power of 7, 2 by 2 by 2 by 2 by 2 by 2 by 2. One more. And then 2 to the power of 7 will give you 128, and you can put that directly into the calculator. Then we have 2 to the power of 8, so 2 by 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 2. 2 to the power of 8 will give you 256. And then finally 2 to the power of 9, that's 2 by 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 2. 2 to the power of 9 will give you 512. So that's that one filled out. So we'll go on to part B now. Okay, so for part B, if we read the question there first, so Maria wins a prize in the lottery and is given 2 options. So option A is that she takes €1,000 cash home today, or option B is to take €2 today, €4 tomorrow, €8 the next day, and it doubles every day for 9 days. Which option should Maria choose if she wants to get the most prize money? Explain your answer. So what we need to do now is figure out which option will give her the most money. So the first option is to just take €1,000. Now the other option is that the €2 doubles every single day for 9 days. So option B would be if you have 2 to the power of 9, because it doubles every day for 9 days. Now 2 to the power of 9, if you put that into the calculator, it would give you €1,022. So the option that she should choose if she wants to get the most prize money is option B. And you have to explain your answer. Well, with option B, she would get €1,022, which is €22 extra. So that's what I'm going to write down. So with option B, she would get €1,022, which is €22 extra than option A. So when you're asked to explain, you need to justify your answer. So explain why you're saying that B would be the better option. And I've shown there that 2 to the power of 9 would give you 1,022. So that shows that B would be the better option there. So I've pulled one final question here, and this is from 2014. And it's also paper 1. So it's the tail end of a question. And this question, it says, so 3 to the power of 8 is 6,561. So I'm just going to write that out. So we are told that 3 to the power of 8 is equal to 6,561. And what you were asked to do is to explain how you could use this to find the value of 3 to the power of 9 without using a calculator. So the key thing there is without using a calculator. So there's 2 ways you could do this. The first way you could do it would be 3 to the power of 8 multiplied by 3 to the power of 1. That would give you 3 to the power of 9. So 3 to the power of 8 by 3 to the power of 1 would give you 3 to the power of 9. Because remember, when you're multiplying, if they have the same base, you can add the exponents. You can add 8 and 1, that would give you 3 to the power of 9. Now another way of doing that would be, so we are told that 3 to the power of 8 is equal to 6,561. So if we were to do that out, it would be 3 by 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 3. That's 3 to the power of 8. That gives us 6,561. Now, that's 3 to the power of 8. So if we were to multiply 3 to the power of 8 by 3, we'd get 3 to the power of 9. So we could multiply 6,561. We could multiply that by 3, and that would give us 3 to the power of 9. And you could do that, you could do it long multiplication out in your rough work to give you the answer. If you were to do that out in rough work, you'd get 19,683. Now they're not actually looking for that figure, they're just looking for ways that you could do it. So that's the first way you could do it, or you could do it this way. So either of those will work. So that's it on the laws of indices and applying them to different questions. I will paste in some extra links to some extra notes and material that you will find very useful in this particular topic, and I will talk to you next week.